Hey everyone, it's Mrs. Marcellus in Froganachi. Today we're going to learn about terminating and repeating decimals. Today's learning objective: students will write a fraction as either a terminating or a repeating decimal by dividing the numerator by the denominator. Hey, that sounds kind of familiar, doesn't it, Froganachi? Our students know that every fraction is a division problem, so I bet that's going to come in handy again today, don't you think? All right, let's proceed with our vocabulary. Our first word is rational number. A rational number is any number that can be written as a fraction. This includes our set of integers, all fractions, all terminating decimals, and all repeating decimals. This diagram shows how the sets of numbers are related to each other. In the center we have the whole numbers, which are the positive numbers on the number line. Then we have the integers, where we add in the negative numbers, and the rational numbers puts in decimals and fractions. And this includes everything except for irrational numbers, and those are numbers that go on and on forever, never repeat and never end, such as pi and phi. It's not necessary to record this diagram in your notes. Our next vocabulary word is terminating decimal. This means it comes to an end. When we divide the numerator by the denominator, we keep adding zeros and bringing them down until we have a remainder of 0. Some examples of terminating decimals are 3/4, which equals 75 hundredths, and 5/8, which equals 625 thousandths. We also have repeating decimals. In a repeating decimal, something repeats. It might be a single digit, it might be multiple digits, or it might be digits that start to repeat after a couple of individual digits. For example, we have 1/3. 1 divided by 3 equals 0.333, and it goes on forever, repeating. We write this as 0.3 with a bar over the 3 to indicate that the 3 repeats. We also have 5/12. This equals 0.41666 repeating, so we would write that as 0.41 with the bar over only the 6 because it's only the 6 that repeats. When we write a bar over a number to indicate that it repeats, this is bar notation. The repetend is the name for the pattern that repeats. For example, in 1/3, the repetend is 3, and in 5/12, the repetend is only the 6. Are you ready to try some problems converting back and forth between fractions and decimals, including negative values? All right, you're very brave, Froganachi. Let's try a few. In our first problem, we're going to write the fraction as a decimal. As you can see up in the corner, I have the math Bermuda triangle. This is to remind us that every fraction is a division problem. We're going to take the numerator divided by the denominator. When we do that, we end up with the result of 0.7 repeating. The 7 just goes on and on. So we want to write that using our bar notation. When we use bar notation, we put the bar over the digit or digits that repeat. In this case, the digit that is repeating is a 7. Our proper answer is 0.7 with a bar over the top of a 7. Some incorrect answers would be 0.77 with a bar over both of them. There's only one digit in the repeating pattern, so there should only be one digit under the bar. Another incorrect way to write this is a 7 and then a 7 that starts to repeat. Also, if you're using a calculator, you might see this happen. After several 7s, you're going to see the number 8. This is because your calculator rounds the value. This does not mean that this number suddenly turns into an 8. So when you're writing these values down, you want to take that in consideration and realize that it still is a 7 that goes on and on forever. Sometimes we will see negative fractions, but that doesn't change anything about the process. This fraction is still a division problem. To write this as a decimal, we take 4, divide it by 5, and we get a result of 0.8. The only thing we have to remember is this is a negative 4/5, so our answer is a negative 8/10. Let's write negative 3 and 9/44 as a decimal. Just as when we worked with positive mixed numbers, we don't have to worry about the whole number. We know that we're going to have that in our answer, so we can start by writing negative 3. Then we convert the fraction to a decimal. Divide 9 by 44, and you get an answer of 204545, and so on. So we can see that 45 is a repetend, or a repeating pattern. Our final answer then would be negative 3.2045, and we write the bar over 45 because that is the part that repeats. Leaping Larry was snacking on flies. He caught 7 of the 11 flies he attempted to eat. Write the fraction of flies caught as a decimal. The first thing that we need to do is create the fraction. Larry caught 7 of 11 flies. Next, we need to turn that fraction into a decimal by dividing the numerator by the denominator. When we do that, we get 0.6363, and so on. 63 is a repetend, or a repeating pattern, so our correct answer is 0.63 with the bar over both the 6 and the 3. Let's try writing some decimals as mixed numbers or fractions in simplest form. When we have a decimal, we say it, write it, reduce it. In this case, we have negative 3/10. I can easily write that as negative 3 over 10, and in this case I can't reduce it, so that would be my final answer. Let's write negative 45/100 as a mixed number or fraction in simplest form, and it would be negative 45 over 100. I then can simplify the fraction by dividing both the numerator and the denominator by 5. This gives me an answer of negative 9 over 20. Our next problem is negative 7 and 8/10. This will be a mixed number. I don't have to do anything with the 7, and I write the point 8 as the fraction 8/10. Both 8 and 10 can be divided by 2, so my final answer is going to be negative 7 and 4/5. Let's find the absolute value of some rational numbers. Absolute value is the distance a number is from 0. In this case, we want to know how far negative 4.3 is from 0. We can use our number line, and we have 0, and down here we'd have negative 4 and negative 5. And negative 4.3, or 4 3/10, is somewhere between negative 4 and negative 5. I want to know the distance from 0. How do I get from 0 to negative 4 3/10? The absolute value of negative 4 3/10 is simply 4 3/10 units, or 4.3. Absolute value applies to fractions and decimals in the same way that it does to whole units. Let's find the absolute value of 5/11. The distance 5/11 is from 0 is 5/11. So the absolute value of 5/11 is 5 over 11. Well, Froganachi, wasn't that great how we were able to apply things we've already learned in today's math lesson? And I bet you're really happy it's over because it's snack time, right? Well, we're off to get some flies for Froganachi and a cookie for me, so we'll see you later, math students.